Hello everyone, thank you for joining this session. I'm Alexi Tessier, part of the product management team at LUCID. In this session, we'll showcase how the LUCID Triton Smart camera equipped with the Sony IMX501 sensor brings AI processing directly onto the sensor, eliminating the need for cloud or host system. We'll explore how the on-sensor AI enables real-time, low-latency decision-making, and we'll review the toolsets that are available to train and deploy AI system, making the integration more efficient and accessible. Before we start, we can introduce Lucid Vision Lab in just a few words. We're a machine vision camera manufacturer, making line scan, area scan, and 3D cameras. We have 4 main cameras family, all of them based on the gigabit Ethernet interface, available at speed of 1 gigabit, 2.5, 5 gigabit, and 10 gigabit, and very soon 25 gigabits. We have, as of today, over 100 unique camera designs, with all product designed and manufactured in Canada. Our company headquarters is in the Vancouver area, British Columbia, and Lucid has satellite offices in Germany, China, Taiwan, Korea, and Japan. When we look at the machine vision ecosystem and its development in recent years, the pace of the innovation in the machine vision industry has accelerated. That has been driven by the adoption of newer sensors with faster speed and higher resolution, and that has led in turn to the introduction of higher bandwidth interface. On the application side, we also saw the diversity and complexity of inspection tasks carried out by the system have increased and the burden on the backend system. The AI development is advancing in various fields. However, there are several obstacles to the implementation of AI in machine vision. First, the high implementation costs, such as GPU for AI processing, and the expertise required for AI model development, and the difficulty into going into productization, especially for AI deployment in machine vision. There's 2 options: going with a hybrid system where part of the processing and training is done on the cloud, and the other option is to go more at the edge. And for that, while it's easy to get proof of concept going, there are a lot of hurdles to make it products ready for industrialization. One of the major challenges for that is to be able to go from the initial testing, typically with for an edge AI analytics with a development kit from various SoC or AI processor vendor, towards something that can be deployed in a rough industrial environment, in a factory typically. That's where Lucid comes in. Lucid has a long experience making cameras at scale, dealing with extended operating life, operating range, and temperature, but also sustaining the camera over its full life cycle. That's what we propose to bring with the Triton Smart. We'll explain in what makes it a unique offering on the market, we think. So that's the Triton Smart camera. It's based on our tried and tested Triton platform. That's an IP67 29 by 29 1 gigabit camera. And at its heart is the Sony IMX501 intelligent sensor. It's a 12.3 megapixel rolling shutter sensor that has on-chip stacked with the pixel array and AI image processing units. It offers 100% offline on-sensor AI processing, which saves on bandwidth and alleviates the load on the host PC, minimizing cost and latency. To make the best use of it, we have worked with our partner to really develop the toolset to enable very low entry cost and low pre-existing skill requirement to deploy an AI system, an AI analytics onto the camera. As mentioned, these share all the attributes of a regular Lucid Triton camera. It's what we call a factory tough camera. It's been designed to sustain shock and vibration. It's tested and rated up to 20 G shock and up to 10 G sinusoidal vibration. It has EMC immunity with various industrial grade standard. It's dust proof and water resistant with its IP67 design. And the camera supports power over Ethernet for image data transfer and power input. It uses industrial grade sensor, M12 CAT for the Ethernet connection, M8 for the GPIO, and it's die-cast aluminum case make for a small design with excellent thermal management. It's built and designed and built for 24/7 operation in a challenging industrial environment. The heart of the Triton Smart, or the brain if you want, is the Sony IMX501 intelligent vision sensor. For that sensor, Sony leveraged their extended know-how about building image sensor. They are very strong knowledge about building good pixels, building good image sensor. So it's using a 12.3 megapixel rolling shutter sensor, but it's been combined with an AI processing unit that's stacked on the sensor. Directly under the pixel array is this dedicated processing unit for running AI on sensor. The Triton Smart has effectively two parallel processing pipelines. The first one is the AI processing unit. From the pixel array, we have a first step of pixel correction, and then that goes through the AI ISP on sensor. That will process shading correction, manage the exposure, gain, and white balance, conversion from the Bayer raw to a full color output, and then a stage where the image will be cropped and scaled to create what's called the input tensor. The input tensor is a lower resolution image that will be fed into the AI engine. Depending on the AI model we deploy, the size of the input tensor is anywhere between 256 by 256 to 512 and 512. The AI engine processes the image and output the inference result as a tensor, the output tensor. Then from that point, both those input tensor and output tensor are fed into the camera FPGA. The camera FPGA adds those to the chunk data. We use regular GigiVision chunk data to transfer that. And those are transmitted together with the image onto the Gigi network. The second pipeline is a regular machine vision pixel pipeline. The sensor has a separate shading correction stage and ROI and binning like any typical machine vision camera that then feed into LUCID standard ISP where we process all gain, debayering, color conversion matrix, lookup table, gamma, color space conversion. Both those standard image, the full 12.3 megapixel output, and the inference input and output, input tensor and output tensor are transmitted at once through the 1 gigabit Gigi interface. To train and deploy AI network, we've worked with Sony and their partner Neurala to qualify Brain Builder for Triton Smart. Brain Builder is an intuitive AI training tool. It's designed to efficiently create, train, and deploy custom AI model with minimal coding experience. Once the AI model is created using Brain Builder, we provide LUCID ArenaView MP. MP stands for multi-platform. That's the standard LUCID viewers that can be used to upload the model, acquire the image, and display the inference results inside a single application. So Brain Builder for Atrios. Atrios is the service that Sony is developing around the IMX501 sensor. It provides an interface to train AI model with no coding requirements. All models can be trained and evaluated through an intuitive GUI interface. There is no requirement for any expensive hardware. Brain Builder is available both as a CPU-based training. It can also support GPUs for faster training, but it's not a mandatory requirement. And it's been designed to work with small datasets. One of the hurdles going from general AI into what's in need for machine vision, typically a customer in a factory cannot produce thousands of training image of the same piece, or especially if we are talking about analyzing defect, it's hard on a factory line to actually produce defect and train with them. So Brain Builder and the models that comes with it have been really designed to rely on a few hundreds of pictures instead of several thousands of pictures for the best results. The supported AI model with Brain Builder, there are 3 as of today. Sony is working on more for the future. A classification engine, the classifier will identify type and location, will classify the image based on predefined label. It can categorize object fast and accurately, and it's suitable for classifying clearly defined good and defective units. Typically, a full piece assembly, we have a reference of what's the good unit. It will be able to classify what's a not good unit. The second model is the object detection. This one will identify the type and location of multiple objects in a single image. It's suitable for counting and detecting multiple targets in a single image. And the last one that's only available with the Pro version of Brain Builder is the anomaly detection. It identifies deviation from normal pattern and determines whether an image is normal or an anomaly. It can also localize area of possible anomaly and display it as a heat map. It uses few anomaly image for validation. There's no requirement to provide any anomaly image for training. You can train only on good images. And it's suitable when anomalies are rare and their patterns are varied. The classifier on the other end, if you have, let's say, well-defined good and not good case, will be better suited and easier to deploy. The anomaly is more for random, not very frequent anomaly occurrences. Those are the 3 versions for Brain Builder. Initially, Lucid has decided to resell only the basic version that starts at $285 for a 6-month license. This version supports the classifier and the detector, not the anomaly detection. You can have up to 10 datasets in parallel on the same installation. If you need to go over, you either can upgrade to the standard version or you can remove one of the existing datasets. Once the model has been trained, tested and validated, it needs to be deployed to the camera. The upload of the model to the camera using the standard GeniCam file upload mechanism. ArenaView MP will let you upload those various files, multiple files before the label, the network, the actual AI network, and also other metadata are required. Here we have uploaded them. We run the acquisition as a standard Gigi Vision camera, and ArenaView MP will know the format of the output tensor. The output tensor contains the inference result and will overlay the result on screen. That's the bounding boxes we see here. ArenaView MP is just a GUI. Of course, we support all of that through our SDK for customers that need to build their own custom application with the Triton Smart, the same feature set, the same AI model upload and output tensor decoding will be supported on the SDK level as well. And here's the workflow for Triton Smart. There is one key element to be able to get good training results with a limited data set is to acquire the imagery in situ. Acquire the imagery with the Triton Smart camera and you in the setup where you intend to run the analytics and use that for training. So the first step is to have the camera with the Triton Smart, acquire images and save them. Then the data can be uploaded to Brain Builder, and that's where we label the image and we train the AI model, verify it. Once the model is trained, we can upload this through ArenaView MP. There's small conversion step required to match the format that the camera is expecting, and then we can upload those models. Then all model run on sensor. The frame rate of the analytics can run up to 30 FPS. However, because of the full 12 mega image cannot be transmitted at that full speed, if you, in addition, transmit the full 12 mega image, the maximum speed is around 8 frames per second. If you reduce the size of the raw image, you can actually run the analytics faster. And now for a short demonstration of that. This is one of the trade show demo we've been showing around, and we have just recorded how we trained that model. So the first step was to acquire the input tensor. For the best result, we want to train with the actual input tensor. So here it's a 320 by 320 pixel image. That image comes straight from the AI ISP on sensor. It's been cropped and downscaled on sensor. We just save those images. Because we use the object detection, we want to have multiple objects. We want to have the object partially included in the frame. Once we have those datasets, I think for that training, we use a couple hundred. We go through Brain Builder, we create our project name, and here we can select our datasets. We have decided to use the detector model for this one. And we just upload the data. It says upload, however, Brain Builder runs entirely offline on a standard computer. There's no cloud training required. So yeah, 212 files have been used for that. Once we have updated the file, we can go about labeling them. That's what we'll see in the next step. Here we have different classes of objects. Those are simple stationary items that we use for that demo. Obviously, you can use various other things. So here we just define our different object classes. And the next step would be to draw the bounding box for those. Here we can draw the bounding box around the object. We can as well add new label from that view. If for some reason one of the object type was not input at the previous step. So here we can label in a single image multiple objects. That's the detector that will detect and locate multiple objects in a single image. Once we have labeled all training data, we can train our model and review. Training is done on, the training speed will depend on the specification of the PC that's used for training. If we use CPU-based training, it's longer, obviously. If we have one of compatible NVIDIA GPU on that PC, we can use the GPU edition of Brain Builder for faster training. That training took several hours. There's different options: quick, balanced, and thorough. The advice is to start with a quick training, review the results in Brain Builder with the validation, and potentially retrain if needed. If not, go with uploading to the camera and confirm. You can always come back and retrain with the thorough or the balanced version for better precision and better accuracy of the AI analytics. Our model has been trained. We are satisfied with the result. We can download the brain. The brain is the trained AI model. That comes in several files for the model itself, the spec of the output tensor, and the various classes. Here, using ArenaView MP, we upload the model to the camera. That takes a couple of minutes. Once it's uploaded in camera, we can just connect to the camera as a standard Geeky Vision camera, and if the AI model is uploaded, the AI processing will run automatically. ArenaView MP will see the output and display those bounding boxes. That's a demo you may have seen on various trade shows all over the world. Most recently in Taiwan, we had this being displayed. So that's it for this session. In summary, the Triton Smart is what we call an intelligent vision camera. It's a 12.3 megapixel, 4000 by 3000 pixels rolling shutter camera with, at full speed, can transmit at 7.9 frames per second. The on-sensor AI inference can run at up to 30 frames per second. That's dependent on the actual image transmission bandwidth. That's based on the Triton IP67 1 gigabit PoE design with a size of 29 by 29 by 45 millimeter, with a list price of $495. To pair that is paired then with Brain Builder for AI training. It's a no-code AI training tool. It allows easy build and deployment of quality AI. It's optimized, the model it provides are optimized for this sensor and this processing unit, the Sony IMX501 intelligent vision sensor, with a starting price of $285 for a 6-month license. If you want the other version with the longer license or the anomaly detection, that will be a more expensive license. That's it for today. If you have questions, I think you can leave them now in the chat, and we'll come back to you after this session. Thank you very much.